Take this problem of problem 58 of your textbook. Oh, this problem, I have seen that this is apparently it's a easy problem, but only thing there is a small catch. The two blocks have equal masses. Let's read the problem. Let us say this mass is also m and this mass also m. This is very good. Having equal masses, then momentum equation will be easier. Surface of A, the catch is the surface of A is smooth. That means there is no friction between A and the table. This is mu equal to 0. But the surface of B has a frictional coefficient of 0.1. That means here is a mu is equal to 0.1. This is the catch. Now the question is, block A is moving with a speed of 10 meters per second, that we have already written, fine, towards B, which is kept at rest. Its velocity is 0, kept at rest. Find the distance traveled by B. How far B will travel? The B will travel, say, to this distance after the collision. And they want us to find out what is this distance traveled by B. Nothing else. Just you have to find out the distance traveled by B. But in two different conditions. One condition is collision is perfectly elastic. Another condition is the collision is perfectly inelastic. So let us take the part A first thing first. If the collision is perfectly elastic, then here, from the theory of conservation of momentum, I write in a simple way, conservation of momentum theory is momentum of the first body m into its velocity 10 plus momentum of the second body is 0 because it's at rest is equal to the velocity of 1 into its mass plus mass into mass m velocity of v2. Say after collision, their velocities are v1 and v2. We have been writing this repeatedly many times. From here, we have seen that m gets cancelled. So what we are left with is v1 plus v2 is equal to 10. v1 plus right? One thing. But there is one more point, very interesting. Here, the two masses are same. Masses are same. Masses are same. And the second body was at rest. And the collision is perfectly elastic. Now, recollect your theory classes. In such a case, if the collision is elastic and the bodies of masses are same, and the first body was in motion, second body was in rest, then after collision, second body becomes at rest sorry, first body becomes at rest and second body moves with the same velocity of the first body before collision. So therefore, so V2 will be equal to U1 will be equal to 10 meter per second. Right? Now, what is the kinetic energy of V2? Now, because here it's not given in the problem, but see, if you come to this equation, if V2 is equal to 10, V1 becomes 0. That will happen if the two masses are same. Now, kinetic energy of B of into M into 10 square is equal to M Joule, 50 M Joule. Its kinetic energy, B will move. Now, force against frictional force. Let us write frictional force. Frictional force against B is equal to mu, and reaction force is mg, mu mg. Frictional force is mu mg. Frictional force is mu mg. So what is the work done by B? If it moves a distance of, say, s, then work done by B is mu mg by s. So work done against friction equal to mu mgs. And this mu mgs has to be equal to its kinetic energy 50 m. So mu mgs is equal to kinetic energy 50 m is the kinetic energy. And mu mgs is the work done. From here we get m gets cancelled on both sides. M gets cancelled on both sides. We get mu gs equal to 50. So mu is given as 0.1, is given as 0.1 here. G is 10. S we have to find out is equal to 50. From here, we get 1 into 10 is equal to 1. So we get S is equal to 50 meter. So the body B will move by 50 meters. This is clear. Now let's find out how far it will move if the collision is perfectly inelastic. So if the collision perfectly inelastic, the collision is perfectly inelastic, then perfectly inelastic means M1, M and M, both A and B will join together. So if it's perfectly inelastic, then once again from the conservation of momentum theory, the initial momentum was 10 into m will be equal to the two bodies joined together m plus m into its velocity v. Consider, say, their combined velocity is equal to v after collision. That is so. If that is so, therefore, what do you get? 10m equal to 2mv. So we get v is equal to 5 meter per second. This is absolutely okay. Now we have to be a little tricky. Okay, also let us find out. So kinetic energy, let us find out the kinetic energy is half into 2m into v square is equal to half is equal to m. V is 5, m into 25, or let us write in a standard method, kinetic energy is equal to 25 m. So this time, what is the friction? There is the catch of this whole problem. After, let us do it, let us write this a scenario after collision. Scenario after collision. Both A and B, they have stuck together, A and B, and both are moving with a velocity v, but the friction here is 0, but there is a friction here. Frictional force is, because there is a friction between B and this friction here is more than 0, but friction here is 0. So frictional force remains same. So frictional force F is equal to only mu mg. It is not mu 2m into g. Let this be very clear. Now, by distance say d, then work done is mu m g multiplied by the distance d is equal to this kinetic energy 25 m. What do we get from here? This m and m gets cancelled, and what we are left with, mu is 0.1 multiplied by g is 10 multiplied by the distance d traveled is 25. So 10 into 0.1 is 1. So distance d is equal to 25 meter. 25 meter. So in inelastic condition, they together move by 25 meter. And in case of elastic condition, the body A just stops at the collision and body B moves by 50 meter. So this was the solution of this particular problem. Now we shall go to the next problem.